So this is going to be about solving absolute value equations. And this may be review for you, but just as a refresher on the absolute value in general, it's defined as the distance to zero. And what that means is that once a value is inside the absolute value, or if you take the absolute value of a number, it makes it positive because you cannot have a negative distance. So if you're taking the absolute value of -2, that's going to be 2. And the absolute value of a positive number, like 17, it remains positive. So let's think about what that means in practice for an equation. Again, any equation, you're just solving for the variable. And, a basic way to think of an equation is any value that works is an answer. And so if you think of something like this, and you need to come up with a true statement, you're saying, well, what values can I plug in for x that will produce 5? And obviously, one of those values is 5, right? The absolute value of 5 is 5. But another value that works is -5. If you understand what the definition of an absolute value is, the absolute value of -5 will also produce 5. So both of these are going to be answers. So here's the steps for solving an absolute value equation. And, the whole idea that there can be a positive and a negative for each of these is why you have to do the second step here, where you set up two different equations, one looking exactly the same, and the other one, being where you have to multiply usually the right-hand side by -1 so that you can take into all accounts the positive value and the negative value. But make sure that you check your answers, because occasionally you'll have what is called an extraneous solution, which again means that you've solved it correctly, but those answers simply won't work because of the nature of an absolute value. And when you check those, make sure you go into the original equation. So I'm going to work through a couple of different examples for you here. I'm going to start off with a fairly basic one because we can skip step 1 there. As you can see, we have everything that is outside of the absolute value symbols are already on the right-hand side. So we can just move to the next step, which is to set up two different equations. And when you're setting up your two equations, remember that the first one is just going to look exactly the same, except we remove the absolute value. And the second equation is going to look almost exactly the same, except we have to multiply everything on this side by -1. All right, so we've set them up, so let's go ahead and just solve these. So the first one here, I'm going to subtract 2x to the other side. And we have x plus 1 equals 3. Subtract 1, and so then x equals 2. Now we're going to, we might as well check this one while we're already here. And so I'm going to go up into the original, and make sure you always go to the original. You have to check these with the absolute value, otherwise it's not going to give you the information you need. So I'm going to go back and say, well, let's see, does the absolute value of 3 times 2 plus 1, does that equal 2 times 2 plus 3? So the absolute value of 6 plus 1 equals 4 plus 3. And so then the absolute value of 7 does equal 7. So we know that x equals 2 is a solution. So now let's go to the second equation here. And I'm going to start off by distributing the -1. That's going to be -2x minus 3. Very important to understand that no matter how many terms are over here, they all need to be multiplied by -1. So you definitely are going to have to distribute if there's more than one term there. And now it's going to be pretty straightforward. I'm going to add 2x to the other side. and get 5x plus 1 equals negative 3. Subtract the 1 and divide by 5. And so we're saying that x equals negative 4/5. But again, we want to check this to make sure that everything is right. Back to the original. So the absolute value of 3 times negative 4/5 plus 1. And does that equal 2 times negative 4/5 plus 3? So then we have the absolute value of negative 12 over 5. I'm going to get a common denominator to save a little room here. 5 over 5. And does that equal negative 8 over 5 plus 15 over 5? Okay, so then this is going to be the absolute value of negative 7/5. And does that equal 7/5? And sure enough, it does. So we know both of these are solutions to this absolute value equation. So here's a quick one for you. What this is saying is what value of x can we plug in here so the absolute value of everything inside gives you negative 14. Well, that should send up a red flag right away, because there's no way you can take the absolute value of something and get a negative. So this is, if you notice this happening, you can right away say, no way, no solution, empty set. Okay, now be careful with this, because if there is a variable right here, then it doesn't matter what the negative sign is doing. Okay? As soon as a variable is added, then this whole process changes. So this is only true, it can only be no solution if the right-hand side produces a negative integer or fraction, negative real number, we should say. Anytime there's a variable over here, you got to go through the process. Okay, so this will be the last example I do, but this will go through all of our steps, because you notice that we have a couple different numbers that are not on the other side of the equal sign here, and that should be the very first thing you do no matter what. So let's go ahead and add 3 to the other side. So we'd have 2 times the absolute value of 3z plus 1 equals 12. We're going to divide by 2 and have the absolute value of 3z plus 1 equaling 6. Now that we have all the numbers that are outside of the absolute value symbol to the other side, we can set up our equations now. So one of our equations is going to be just exactly the same. Without the inequality, and the other one is going to be almost identical to that, except we have to multiply the right-hand side by negative 1. So I'm just going to solve the blue one first here. We're going to subtract 1 and divide by 3. And let's finish off the green one too. So then it's going to be 3z plus 1 equals negative 6. 3z equals negative 7. And finally z equals negative 7/3. So remember, we do have to check these, and we have to check it into an original. Now I would say that this works just fine for our original. You don't have to go all the way back here, because you should have manipulated it correctly, and you would have this is more simplified. Oops. So let's check these up, make sure they look good. So then we have the absolute value of 3 times 5/3 plus 1. And does that equal 6? Well, 3 times 5/3 is 5. The absolute value of 5 plus 1 does equal 6. So we're happy with that one. And we're going to check this final one. Absolute value of 3 times negative 7 over 3 plus 1. And does that equal 6? And so then we're going to have the absolute value of negative 7 plus 1. Which is the absolute value of negative 6 equaling 6. And so then we are happy about that also.